So today we'll start with a little review of what we learned in week one. Just to before we get started into like the second part, which is learning about databases. So the client server model, clients are computers and servers are also computers. And the clients can send a request to servers, and then the servers will reply with a response. That's what we learned last week, right? And the requests, they're initiated by a client. You send it to a specific URL. The URL contains a domain, like google.com, has a route path like the slash search, and it has the URL parameters. For example, like last time the query or like the ID of something you want to like update or something. And the method, remember, indicates the nature of the request. So we have CRUD, which was create, retrieve, update, and delete. Those were the four like methods we use to create our backend. And also we had the body of a request, which we sent using JSON format. And that's just to send like large amounts of data or just any meaningful data other than like IDs and like simple integers that you can put inside the parameters. So yeah, moving on. We have responses. Responses are triggered by client requests, and they return confirmation of the requested operation. We have response codes like 200, 404, 500, and they're used to indicate the success or the failure at an more like abstracted level. So you immediately like recognize that like it's an internal server error. And it also sends JSON data in a body, just like a request. It sends it back to the client. So same diagram as last time. The client sends a request to the server. The server will then process it with like the route is triggered. It will process the data and then it'll return a response with a body that's in the form of a JSON back to the client. Um, yeah. So now that was a really quick review. Any questions? Like I hope there are like no questions because that was like a really quick review because we want to get into like the beef of today's topic, which is data persistence. So go ahead. I got you.
Yeah. So just before we get started with what we're doing today, which is databases, we're going to be just reviewing what we did last time. So last time we were storing all of our data with just a Python dictionary. So some of the bad things about this are every time we stopped the server, everything that we did to the data, all of our updates and etc. were lost. The other thing that's bad about this is obviously it doesn't scale very well. Dictionaries are just on your computer, and they're also not optimized to hold a ton of data. And there's also no formatting enforcement, which basically means you could put whatever key value pair you wanted into the dictionary. There's nothing that's saying that you can't do a certain data type or whatever. So that brings us on to our topic for today, which is databases. So the fundamentals of a database, essentially, all it is a collection of organized information. It allows you to easily access, update, and manage your data, and it's implemented as a collection of tables. So we'll definitely dive into that more, but that's just a quick overview. So this is an example of a table. So we have rows and we have columns. Columns will have a name and then they'll have a specific data type. So for name, it would be a string, ID would be an integer, and everything in that column is going to have the exact same data type. And then a row is going to be a set of column values, and that'll represent like one item or one entry. In this case, it's one person. So I have ID 1, an age 20, and a hobby. So you can read me like as a row, and then columns will be all the one data type. So yeah, this is what I just talked about. Yeah, so then your every every table will have a unique identifier. So this basically means it's just some type of identifier that will be uh, unique to this row, and you can use it to identify this row. So in this case, it's an ID, and in most cases, it's going to be unique IDs. So if I wanted to get me, I would get the row with ID 1. And generally, IDs will automatically increment. So that means you don't have to worry about it. Like last time, we were incrementing it manually. Most of the time, it's going to be done for you. The other thing about this is if I were to remove this row, like remove me, basically, and then add a new one, it would not reuse it. So it would just go straight to 4. It wouldn't go back to 1. If you tried to get 1, it would not exist. And that just makes it easier for everybody. Yeah, but that was just one table, and databases are not just table, or it's not just a table, it's a collection of tables. So if we were making Instagram, for example, we might have a table for users, we might have a table for posts, and many more things like stories, etc. And all these tables will come together to make what we know of as a database. So this is just another example of a table, posts, with ID, a name of who posted it, maybe a description like a caption, and an amount of likes. Yeah, and another thing to mention about this is that the IDs for these tables can overlap because if you're trying to get a specific user, for example, you'll say like get ID 1 from table user. And that can overlap with posts. They'll have each have their own unique identifiers. Yeah, and as we can see, this is just so much better to look at than the JSON, and it's going to be a lot more efficient and easier to reason about as well. Do you have any questions just about general like databases before I move on? Cool. So yeah, as I just mentioned, data is very structured in databases. It also scales extremely well, and it's very useful for querying data as well. Basically, everything in databases are optimized for a large amount of data and everything to be accessed efficiently. So this is an example of how we might have gotten all of our users who are over the age of 18 last time. So we'd basically get all of our users from a JSON. We'd initialize a list of over 18 users. And for every user, we would check if their age is over 18. It's all right, but we can do better with a database. So this is all we need to do with a database. So we basically are doing select star from users where age is greater than 18. So we'll break that down more, but just as a quick overview, the star means all. So what we're doing here is we're getting all users when their age is greater than 18. So you can see this is so much simpler, and we're going to go into how you can implement something like this soon. So the way that we do that is with structured query language, which Josh is going to talk about.
Yep. Right. So what you saw just now, this snippet that Sky showed you, that's a snippet of SQL. And SQL just stands for structured query language. Or SQL, as most people like abbreviate by, but just try and say it as SQL because not a lot of people say it as like SQL, and some people might flame you if you call it like SQL. So yeah. So an overview of SQL. It's a language for communicating with databases. It's different from Python. It's not Python. It's a different language, and it's meant to be for databases. There are lots of different types of SQL. So like we have like SQL for what we're going to use in Python, which is SQLite 3. There are SQL for like different other database types. Like for Postgres, for example, it's called pSQL. And there's like so many other like languages that are based on SQL, but they just have their like different little differences. And what they do is you can execute like requests, like it create, retrieve, update, and delete. So these are CRUD operations. You can execute CRUD operations using SQL. Yeah, so here's the first like the first operation we're going to teach you guys. It's going to be creating a table. So remember how in one database you can have multiple tables, and this is the way to create like a single table. So the keyword is create table, and then you put the table name here, and you have the brackets, and inside the brackets you have all the columns you want to have with their corresponding data type. So it'll look something like this. So if we're going to create a table called user, we're just going to do create table user, and then brackets, and we're going to list every single column inside that database. So column 1, ID, and then we're going to have all the attributes. In this case, it's quite a long one for the ID. So the ID number 1 is going to be an integer, and it will also be our primary key. What primary key means is that it will be the unique identifier inside our table. So if you're making a, like, for example, the second one, like name has, it's going to be text, so it's going to store text, and then we have another attribute that's not null, which means that column can never be not null. So like a user cannot have no name essentially. So we're setting it so it's not allowed to be null. Null as in like nothing, right? In this case, like for name, what if two users had the same name? Like what if there are two Joshuas or there are two Skies? We wouldn't like disallow the user from doing that. We could have two Joshuas. However, for the ID, we do not want to have like two like number 15s. So that's why we have the primary key. Primary key ensures that the integer inside ID is unique. So we'll never have duplicates of like 15 or like 13, for example. However, in the other columns like name, age, email, if I don't put primary key, they're allowed to have duplicates. So they can have like two people with this age 18 or like people with the same email maybe, but that's kind of weird. But yeah, and then the third one for ID is auto increment. And what auto increment does is, the name suggests, it increments the ID as you create new users automatically. So remember how last time we were storing like the user like the task ID for our to-do list app. We were storing the task ID and we're updating it like add one every single time we make a new task. In this case, the database will do it for you. So you just put auto increment, and every time you create a new user, the ID will increment by itself, like +1, +1, +1. So yeah, that's how you do it. You just create table user and then put the columns with the attributes. And yeah, maybe like for this one, the fourth one, email, it's of the type char, like char 50. And that just stands for characters. So we're allocating 50 characters for email. So the email has to be within 50 characters. So that's how you create a table, and that's how you like initialize like the columns in each table. All right. The next one is going to be inserting data. So if you want to insert data, you want to add a user to a users table, you're going to do insert into table name, and then you're going to specify which columns you want to add to. So you just put in the columns in this bracket, and then you're going to have another keyword values, and you're going to insert the values you want to put into the table. So an example of this would be like this. Actually, wait. All right, there's an extra slide in here. So if you're inserting everything into the table, for example, column 1 all the way to column n, you can actually omit the columns if you're adding all of them, because this is just a cleaner way of inserting data, because you don't have to specify every single column. But this is only if you're adding to all the columns. So an example of this, yeah, this is bad practice, but an example of this, oh my God, there's another one. It's bad for readability and it changes in column order breaks it.
Yeah, basically like
Yeah.
if you do omit the column names, generally it's not considered good practice, because if your database changes at all, it can totally mess this up. Also, like just for readability, if you're trying to see which values are being added where, you have no idea as the reader unless you have the columns there. So that was just
Yeah.
why it's bad practice.
Yep.
But you can't do it.
Yeah. So yeah, finally, this is the example. So like if you want to insert into a user, you're gonna give it the column name, so name, age, and email. And then inside the values, you're gonna put like John 21 and the email. So see how these like line up. So like name and John line up, age and 21 line up, and email and like the email lines up. So in this case, like Sky said, if you don't put this, you might like misorder them. For example, it's completely legal to have like name, email, age, and then you switch the email and age, like 21 and email, you can switch it. That will insert it just fine. But again, if you don't have this like column, like the columns you're targeting, it might like mess up. You might miss input stuff into the database, which no one wants. So yeah. All right.
You want to just mention like why it's all caps and the semicolon as well?
Oh yeah. So yeah, the semicolon is just syntax in SQL. For it to like, that's the end of a statement in SQL. You need to have the semicolon. Unlike Python, you just don't have like the semicolons. Question?
You can put any values at any type into this.
It has to match up with a column that
Yes.
exists.
So
If you switch like JS123 for now, how would that work in the age column that's expecting an integer?
It wouldn't work.
yeah,
would
so
throw an error.
what I was saying just now is like you would switch age and email, and you'd also switch these. So then that would also work. But like if you didn't have this entire, if you like omitted this part, like the columns, and then you switch these, then you would try put this string into age and this string into email, then that would like cause the issue. That's why it's bad practice to omit it, and like sometimes you like only if you have like all of them, then you want to like omit it. But generally it's good practice to like have all of them when you're like not doing everything. But yeah. Wait, what was I missing?
Oh no, that's all. Also, just like notice that all the keywords in SQL are going to be in all
Oh.
caps, and then all the names that like you provide are lowercase. That's just the
Convention.
syntax. Yeah, the convention.
Yeah. It's just a convention, because you can like make it like non-capital,
Yeah, I
right?
think
Yeah.
you can.
So it is convention to have your keywords like caps, like completely capital, but it's also fine if you don't have it capital, but most people just write it as like capital letters for the keywords. Yeah, moving on, retrieving data. So when you're retrieving data, that means you want to get something from the database. For example, you want to get a user. You'd use the keyword select, and then you would specify the columns you want to get back. So for example, I can select name and select email, and then I can determine or target which table I want to get it from. So I use the from keyword and then I give it a table name. So this, for example, remember how Sky said the star, like this asterisk? This is actually shorthand for all. So if you have an asterisk, that means you're selecting all from table name, for example. And that just gives you back all the columns in that table. Yep. And another way to sort of filter what you want to get. So for example, if you want to get the users that are above 18 years old, you can use this where keyword. So where, and then you can put the condition in front. So for example, here, I believe there's an example. Yeah. So I can select all from the table users where the age is greater than or equal to 18. So notice here how I'm using a column name, like age is a column in our table, right? And I can specify like the age is over than like greater and equal 18. And this will only give me like it'll filter through and only give me users that are above 18. So this is where like it's better than Python dictionaries, because in Python you would have to search yourself, you'd have to filter them yourself. But in SQL, you can just ask, like SQL does it for you. It does the filtering for you. Nice. Yep. And now we can move on to updating data. So this is same like the update in CRUD. You can give it a table name, like table user. So update users, and you can use the set keyword, set, which will change values. So in column 1, I'm gonna replace it with value 1. Column 2, I'm gonna replace it with value 2. And you can also have another filter here, where condition. So like where the users are greater than 18, I can set like their email to be nothing, or I can set their like eligibility to be something. So an example of this would be like this. I can update user and I can set the email to be this email where ID equals 1. So when I want to change like the first rows, like or like the row with ID 1, I want to change their email. This is how I do it. So I update user where the ID is 1, and then I set up the email to become like this email. Okay. And then deleting data. So to delete data, you can use the delete keyword. So delete from, and you give it a table, and again, you give it a condition. So where blah, 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 blah. So in this case, you can do like delete from user where ID is 1. So I'll only delete 1 row from the database. Yeah, that's basically it. Yeah, and now let's go into the demo.
Hello. So the video for the mini demo got corrupted, so I'm gonna go back and just record it so that you guys can follow what we did if you're watching on the YouTube. Yeah. So basically we just went over some of the simple commands we learned and just did it all in the terminal using SQLite 3. So to enter the SQLite 3 terminal here, you just type SQLite 3. It will tell you your version and it will enter this little mini terminal here, SQLite. So first thing that we did was learning how to create a table. So the keyword for that is create table. Then you provide the name of the table in lowercase. And then you do a parenthesis. I can press enter here and it won't send the query or the operation because there's no semicolon. The semicolon ends it. So the first field we want in this is going to be an ID. And as we mentioned in the lecture, that will be an integer. And it's going to be a primary key, so they can't have duplicates, and it's going to auto increment. The other thing we want to have for this example, I'm just going to do people and their favorite food and drinks. So I'll do a name, which will be text, and we want this to not be null because we want everybody to have it. The next thing we're going to add is just a favorite food. And it's also going to be text, not null. And then we're going to have a favorite drink. And for this one, why don't we make it just maxed out at 20 chars, and it'll actually pad to 20 chars, and it'll be a little bit quicker than getting text. Just another example of what you could do. And we're going to not have the not null, so we're going to allow this one to be null, just for fun. and then you close it with a parenthesis and a semicolon. And hopefully that created the table. We can check that by doing dot tables to list all the current tables. And we can see user was created. Perfect. Okay. So the next thing we're going to do is insert some users into this table. So the way we do that, if you remember, is insert into, and then we list the column names in order. So let's do name, favorite food, favorite drink. And then we're going to be entering in the values of, let's see, my name is Sky. Favorite food is pesto pasta. And say favorite drink is iced tea. Cool. And so then we just do a close parenthesis and a semicolon. Oh, what did I mess up? Oh, I forgot to put the table name. Insert into, we need the table name, obviously. So you need insert into user. And that should work now. Then if we try and get all users, I don't know if you remember how to do that, but that's select star. Star means all. So select all from user. And let's see what we have. Make myself a little smaller. We have me, Sky, pesto pasta, iced tea, and I have an ID of 1. And notice I didn't actually have to enter that ID, it just automatically did it. And let's make someone else. So let's do values. Josh. I know now his favorite food is noodles. And it's not give him a favorite drink. We don't require that. Of course, I have to remove favorite drink from here as well. Cool. So we are going to be inserting name and favorite food, Josh and noodles. Okay, that's good. Now if we select all, we'll see that I'm there and Josh is also there. And it's okay that he doesn't have a favorite drink because there's no not null constraint on that. And it automatically incremented his ID here, so we don't have to worry about that. Cool. So what else did we learn to do? We learned to select specific things. So one way we could do that is select, we saw select all from user. We could also select specific columns. So maybe name from user with a semicolon, of course. Gets all the names from our user table. We could select just name and favorite food. So we can select multiple columns from user. Cool. Yep. And let's see, if we tried to select a column that didn't exist, what would happen? Maybe user. What's it say? Yeah, so it says no such column, favorite condiment, which is very helpful. So it doesn't let us try and access columns that don't exist, which is a good thing. All right, so we've learned, we've done GET requests, we have done post requests. Let's do an update. Let's update a user now. So the way we do that, if you remember, it's the update keyword. And then we want to update the table user. And we want to set. And then we provide the column name. So let's do favorite food. And then the value we want to put in there. So let's say how about my favorite food now is mac and cheese. So we'll say favorite food equals mac and cheese. But I only want to change my favorite food. I don't want to change Josh's. So I have to do this where keyword, which will filter it by whatever condition I provide here. And let's see, my ID was 1. So I'm going to say where ID equals 1. And let's see. Cool. If we select all from user again, you can see that my favorite food has been changed to mac and cheese. Awesome. So the last thing that we learned was to delete users. So we could see that I'm here, Josh is here. If I wanted to delete Josh, No, I'm gonna delete myself. I'm gonna delete from user. It's the delete from keyword and then our table name. And then we don't want to delete everybody, that would be bad. So we got to do this where keyword again, and we'll do ID equals 1 again. You could also do like name equals sky or favorite food equals mac and cheese. But we know that ID equals 1 is our primary key. So we want to always identify them with the primary key. And then let's see if that worked. Did. So it's just Josh. And notice it doesn't re-index here. It just leaves him as 2, which is good. Cool. So that's everything that we talked about, all the basic SQL queries. The last thing we're going to do is just how to delete a whole table. So there's a special keyword for that, which is drop table. Then we provide the table name. That's all you need to do. Be careful with this. Don't just drop your tables willy-nilly. And then if we get dot tables again, doesn't exist. So yeah, that's all of the things that we went over in lecture. And the last thing is just how to quit out of here so you don't get stuck. It's just dot quit here. Perfect. Okay. See you guys later.